satellite technology.
That was a satellite that inflated. That was a satellite launched on a rocket into orbit.
Like, what's the net worth of the guy that started the company you worked for? Probably a lot, huh?
Echo 2 or something, Echo 1.
Who ultimately owns your company? Probably a very wealthy person, right? Okay, so he's probably smart, and he's not going to waste his money, and he knows that.
A minute? Is it possible?
This is your standard approach now.
Hold on, Zanic's been trying to get in for the entire day, but just go ahead, Zanic. Let's say what you got to say real quick.
Oh, I mean, I've already lost memory points.
Hello, he didn't have anything to say. He was trying to divert.
Arguing with a rocket scientist that actually manages and
and we're trying to have an actual conversation, and you're inept.
Mute him for a second. Just mute him. Just mute him. Give me like a minute so you can mute him, because I got a headache from listening to him. It's ridiculous.
We respect.
You got a guy here that's spending time trying to help him understand. He's a rocket scientist. His namesake on this discussion, and he works in this field, and he's challenging him on. Don't you think this is fake? Don't you think the information you're getting is from somewhere else, and that we're just getting from high quality military grade balloons that are floating around taking pictures of the entire continent of Australia? I mean, do you see how ludicrous this is?
No.
This conversation is crazy.
Where are all these balloons, by the way? How come we never take video or pictures of them?
They crash out of the sky sometimes. We do have videos of them.
It'd be all over the place, though.
No, once you reach a certain thing, hey, I know you Globers seem to be foreign to this concept, but eventually you can't see
what's
things
giving you what's giving you a GPS signal over the middle of the Pacific Ocean?
Probably what we're discussing right now.
Hey, Zanik, let me give you a quick not Zanik.
Coach, can I just add one thing? I don't want to hog up a conversation. WITSIT, this is your homework for you. You want to prove me wrong, you do this.
Well, that's what I'm saying. Instead of doing this homework I'll just tell you right now that you can see what's going on. From my memory, like Felix Baumgartner, about 20 miles or whatever, you have a radius of about 400 miles that you can see around you, 400 miles. And at the ISS, you have about 1,300 miles.
Felix Baumgartner.
Yeah, right.
But that's not a good level of comparison, because that's not what I'm talking about.
4,000 miles up is when you can finally see the whole picture of the Earth from one observation point.
That's a cool story.
These are the different places that you need to be able to see different amounts of the Earth. And 400-mile radius is not enough to be able to do a lot of the stuff that we claim to be able to see.
What about something that went up 50 miles?
That's what I'm saying. 50 miles, like I just gave you 20 miles.
You can't go 50 miles up in a balloon.
That's what you say.
No, you can just calculate the buoyancy of anything, and you can't go 50 miles up.
The military doesn't have balloons that can go.
No, because what would you fill the balloon with?
Because you just know
that. You can calculate the buoyant force. You can't go up 50 miles on buoyancy.
Okay, so I'm pretty sure I've seen a document where they
show me the document that a balloon can go 50 miles up.
I wasn't about to say that. God, dude, where it says 40 kilometers, which is more than 20 miles.
That's 25 miles.
I know. Okay, so if we are, say, 25 to 30 miles, because we're gonna act like the old documents is the best technology we have when it was 70 years ago, and it's very cost efficient.
Technology thing.
Hang on. I want you to do one calculation only.
Yeah.
Just one. I want you to take the width of Australia, and I want you to divide it by 35 kilometers and tell me what number you get.
But what does that have to do with my point?
I don't care what your point is.
Right, because you're afraid of my point.
You need to do this calculation. Just as a,
dude, you can keep on doing your job. It's not like the whole world's going to end. It does stop spinning, ironically.
What you just said about Echo 1 and Echo 2 and those satellites, like, you have to understand, these balloons are not balloons that left the ground and went up. These are balloons that had to be launched up there already and then inflate chemically up when they were already up miles and miles up. If you're using a regular balloon, it's not technology that's going to get you higher.
But there are at least some balloons up there that have things attached to them that look like satellites, though, right?
Sure. Yeah. I mean,
those things are up there.
Hold on, because you interrupted me to ask that, so I'm gonna stop you so I can finish what I was saying by answering you. The satellites that you're talking about, the satelloons that you're talking about, they look eerily similar to satellites, just like they look eerily similar to that Spot the Dog fucking thing that Boston Dynamics have, because it's just it's just a piece of equipment with sensors on it. That's all they're going to send up there. That's all they're sending up there in satellites. That's all they're sending up there with balloons. They're not going to look wildly different from each other because it's a piece of machinery with sensors on it.
Okay.
So,
but they do look the same, right?
Why would they look different? Like,
well, okay, fair enough, but they look the same. That's my point. You're not disagreeing with my point. You're just trying to drag me through the mud.
No, I'm asking you. I mean, why is that special? Why would you expect two things that are doing, they have similar, missions? They're observing and collecting data and this and that. Why would they look any different?
Well, my point was just that they look the same, though. You're just dragging me through the mud.
Sure, they look the same, but they're different things. One of
well,
them has,
that's your claim, right?
Attached to it.
That's your claim, right? Can you substantiate that? Because what I can substantiate definitively is those things have fallen out of the sky, and that wasn't planned, but it's happened numerous times. Even going all the way back to when the government first started trying to do this shit. And in fact, this was the top type of intel that we could gather when we supposedly had geopolitical adversaries like Russia. And they would crash out of the sky occasionally at crazy speeds.
Have you seen the ones that the satellites, not satelloons, satelloons when they fall to the ground compared to satellites that fall from the ground look like a brand new TV or something like that. When satellites that fall from the sky are burnt up and create these little craters or whatever, and I think one landed in somebody's house.
No, yeah, massive fireballs across the sky. That's not what happened.
No, the video actually shows just it basically fully intact, damn near, just with some damage. And there's more than like 5 of them. And I just told you that this was the way that we could most efficiently gain intel way back in the day. It's declassified. Our military admits it because we had a bunch of these up in the air back then, at the least, and they would occasionally crash out of the sky unpredicted because we were still trying to figure out the best way to make them work. And if you don't think it's possible that they could have those things going very high, very fast, gaining intel in the 70s, they couldn't, by now, 50 years later, put a satellite on it when we've seen them crash out of the sky, that seems a bit naive.
Yeah, very fast and balloons don't go together.
Okay, so you're telling me there's not videos of the U.S. military balloons crashing out of the sky going fast?
No.
Well, it's not exactly a balloon anymore when it's crashing because the balloon has popped now, is it?
Okay.
See,
also, following at terminal velocity is not the kind of very fast that we're talking about when we're talking about
density and nothing. This is a great example of someone having too much information to make them dangerous. That old adage.
Yes.
This is what we've seen.
Well,
I just posted you a Russian satellite. Okay, how does that look?
Wait, no one in the room is going to respond to the premise I said?
I just posted a picture of one.
Just so you know, that's from Walking Dead. That's not real.
Wow, yeah, what a loser. And is anyone actually going to answer my premise or respond to it?
WITSIT, could you please do me a favor and learn how to use the word premise properly?
Well, I'm using it as my argument. So can anybody here respond to my argument?
You're using it wrong.
Well, preface is at the beginning. Preface is at the beginning. Premise is your ultimate point.
Just please briefly repeat
it.
That's your conclusion, man.
Premise is
your starting point.
Preface is your starting point.
Not a starting point.
That's a premise.
Okay, you're right. If you're going, this is the thing. You're assuming that then the explanation follows. In this room, that doesn't happen. I don't even get the original premise out, then explain it. I don't even get the full premise out.
The premise
is the original point that I'm supposed to get to expand on. I can't even get the full premise out.
Yeah. WITSIT.
So you're just pedantic as hell now that you're trying to divert away from my
not
argument.
Part of the argument itself.
So you want me to just say argument? Is that what you want me to say?
Support that you're starting.
All right, dude. So I'll just say argument. Does anyone want to respond to my argument?
We'll get to that afterward, but just
we'll never get to it, guaranteed.
Yeah.
Okay, so it's declassified that we had these and they were the most efficient way that we could gain intel, and we would correlate data between the balloons that were really high in the air over different countries, basically undetectable. At least at first they were undetectable, and we had a few issues, and they documented the whole process of having to figure out these things. And this was a long time ago, starting as early as the 50s.
Okay,
so if you think that if we fast forward 70 years, There's no way that we could have improved that technology, and we've seen them fall out of the sky, and you know that for a fact there's no way that maybe they're not what you think it is. I think it's a little naive.
I'll address your premise with it. Show where'd you look that up so I can go look it up myself.
Okay, I'll try to get the documents, man.
Footage of that launch, and I've seen them do that test and stuff. And you're right that wouldn't the technology have gotten better? And it has. They don't use giant reflective balloons anymore, as they were testing to use, and they use more, useful and versatile, satellites that will send and receive signals and have computers attached to it. Whereas those were just basically giant mirrors, more or less.
Okay, they improved over the years, of course.
True. Hey, does anybody have the picture? I was looking for some last night, the night before last. If 2 rocket launches, one from space and one from the ground, to show the different parabolic paths that WITSIT was alluding to, that looks like they're going into the ocean. I think that would be very interesting for them to see the perspective of someone on the ground watching a rocket launch versus someone up in high altitude, I think it's from a jet or maybe from space, watching that launch.
Well, it can't be from
it's
space.
On Blue Marble Science, and he did a video of that.
If it's from space, that's hilariously stupid, man.
They videotaped launches from the ISS. There's a videotape. I can show it to you.
I'd be interested in seeing like a plane, dude. But I don't want to see the ISS.
You're not going to give me that info with
the ISS is fake.
You're not going to give me that info about the balloons?
So
I can look it up.
What is it that Astronomy Live?
Here you go.
What is it?
Slacker has. That's a great one, by the way. What I'm looking for is there's a picture that has a side-by-side comparison of the trajectory. I think it's from actually a jet at high altitude and on the ground, and you can see the different parabolic paths of the object leaving the ground and going into space.
They did that with the STS. I think it was 94. STS 94. I think there was a jet at about 30,000 feet. Actually took footage of it launching.
The shuttle. I think I've seen that one too. That's the second one. So that one is another one. That's the third one. But there's one that's like 2 that almost look. They're similar paths, but you can tell one's from the ground and one's high up enough to where you see now that it's not going into the ocean because it's above the perception of the Earth's curve. And I thought that'd be interesting for WITSIT to see that this curvature changes as you go up in altitude, and suddenly it's not curving down anymore. It's going along the surface, parallel to the surface. Parallel, as in curved.
Slacker post. That's what I was going to post too.
Yeah. Also, Zanuck, I think Dane, Stingray?
Yeah.
Yeah, I think he actually modeled that and showed how, depending on your perspective, it looks like it's going down. Yet if you actually look at it, you see that it's actually gaining altitude off the Earth. Hang on, Jake. So if you're behind it, it looks like it's going over the curve and heading into the water.
Right.
Yet if you actually go on the side view, you actually see it leaving the atmosphere.
Well, that's why with percent, I was showing those pictures out of Vandenberg, because people that are in California or that are in Central California, they see it curving into the ocean. But people that are 400 miles downrange in Baja, Mexico, they're seeing it gaining altitude, and they're seeing it go into space basically because it's already staged. It's already going up into space at that point.
Did you post that picture?
Yeah, Sfera got the picture I was talking about. Yeah, I'm not sure if that was a satellite or a rocket, STS or rocket.
I like that one. That's a good one. I've seen that one too. But no, there's another one. I was like yesterday, the day before yesterday, 2 side by sides of the 2 trajectories, seeing what WITSIT innocently, mindly thinks that this is going up and going down. And then the same exact launch from a different perspective shows, oh, this is actually paralleling the surface of the Earth, gaining altitude with every second.
Hey, shouldn't we be able to just have somebody else on the surface at a different location closer to the parabolic trajectory that can validate that instead of having to trust the same people?
That's exactly what happens when they launch out of Vandenberg, and people in Baja, Mexico watch it stage and they watch it go higher and higher. And not only that,
but they come
people,
back down.
when it's up that high, people from for all the way Arizona, California, and Nevada, they can all see this thing at the same. They can all see this at the same time.
Gradual incline. How do you know that it's in orbit?
Well, first of all, they know the speed because it goes from leaving Lompoc, California, to being off the shore of Baja, Mexico in minutes.
Okay.
And second of all, they know they can independently verify the altitude by looking the angle of elevation over these distances,
Hey,
measuring
bro.
the angle of elevation over these distances, and doing the math on it.
Bro, if you want to give me
Jake,
the
Jake, he
best,
doesn't believe
if
in
you could cite,
trigonometry
if you
either.
want to give me the
He doesn't
citation
believe in
or like the
trigonometry.
best way to validate what you just said, I am definitely interested in looking at it, bro.
And one
You're
other
not
thing,
going to get me my balloon citations, huh?
He doesn't
yeah, I was
believe in
gonna say
trigonometry.
Scott was asking us a while ago.
See, I was actually compiling. I'm trying to be like the most efficient, but you had to say something. You know, you just had to say
No,
something.
you don't believe in trigonometry. So when we
Hold
start
on,
giving you,
Danny.
I wasn't
Hold
talking to
on,
you.
man.
No
Hold
one
on.
wants to talk to you, man.
Well, just don't. It's not. I don't know. Just to.
Dude
Yeah,
asked me
I'll
about
add
my
stuff soon.
citations. I sent
But
them. I was going to add a few more, but he
no, that's
rushed
fine.
me.
Yeah,
So
no,
there
no.
you go.
I was trying to help Scott out with that. But what was I say? Oh yeah, right. One thing that you can remember when viewing these launches, because there was a GIF in 24/7. I don't know. They probably still post it, but it's one where you see the rocket go up and it looks like it's going back down. But when you watch it and you look at the exhaust is really a good indicator of evidence of not going back down, because the exhaust is consistently getting more and more dissipated as it appears to be going back down. So when you're watching these, you can look for that as well.
I'm not sure this balloon thing is what you are looking for. This is a proposal to use high altitude balloons to drop sensors onto the surface.
Okay, I sent a few different links of military involved
Okay.
with high altitude balloons.
I was just
I'm
looking at
also
this.
looking for the primary
This
doc.
one.
Which do you want it all the way back to like when they first did it, or do you already know that? Specify exactly
Well,
what.
I'm just wondering
part
why
you
you
did you-
included that one, or if you just looked at the title and included it.
I
What?
want, I
No,
want
the
to
one I
ask you for the stuff
sent.
from the 50s that was declassified that you're talking about.
Yeah, I mean you know about that.
I
Right?
have no idea what you're talking about.
Oh, that's okay. See, those
You know,
are the hard ones to
balloons-
find. That's why I hate when people don't know. Now I'm gonna have to go ask someone that like is a truth that has it. You know.
Or were you talking about the Echo 1 and Echo 2, or are you talking about something else?
well, when you see
Well,
the space
that's a
shuttle
good
launch,
example.
when you see the space shuttle launch from the jet airplane, can you see that basic trajectory? Does that comport with what you saw from the surface due to perspective?
I don't believe in the fairy tales of the rockets that get
Yeah,
shot
also-
out
No,
towards the
the
ocean.
space shuttle launch, as viewed from an airliner. Some private citizen did this.
Okay,
Watch
and then
it.
they saw
You're
what?
watching things.
Okay.
They're at 35,000 feet, watching launch from Cape Canaveral.
So what's your
Oh.
point?
Go ahead.
The
Sorry.
point is the trajectory looks.
Is the trajectory parabolic?
So again, someone talks, you got to talk over them. Just let me have this fucking sentence. So the point is, your view of the launch from the ground, it appears that the object is going up and then down and landing in the ocean. From a high level of observation, high altitude observation, you now see that it's nothing like that at all. Perspective is everything here. You like to use that word. Here we go. Here's how it's used with purpose.
Are rockets parabolic?
Pardon me? No.
It rhymes, so maybe you'll be able to remember my premise and not run away.
Is that a parabolic launch?
So rockets aren't parabolic, is that your claim?
Is that a parabola?
Can you just give me a yes or no claim?
This particular
Our
launch
answer.
doesn't look like a parabola to me.
So rockets aren't parabolic, is that your claim?
They can be.
Zanuck, are you just a
That's not the
contrarian
point.
by chance?
It's not to the degree that you
Zanuck,
think it.
chill, man. Chill, dude. God.
It's not a parabola.
You're kind of funny, man. I want to like some of you people, man, but you
It's
just
not a parabola.
chill, bro. You are a contrarian. Do you just
definition of a
argue with everyone in
parabola?
real life too, dude?
Here's the equation of a parabola. Have you
Do you
ever
do this in real life, Zanuck? You
equation
just
that
like someone's
defines a
like, dude,
parabola?
are you like
No, you
are you
haven't.
like Eeyore, but just a contrarian? Like someone's like, it's beautiful outside today. Like
silly.
there's a cloud. Like, do you do this in real life?
It's more like a logarithmic curve.
It's logarithmic.
Okay.
Exactly.
Okay, but
It's not a parabola.
So
So is a parabola logarithmic?
well,
no.
if you want to get very technical, right?
I'm
The
being
parabola.
accurate, not technical. It's fucking simple. This is fifth grade math.
I didn't say it was a parabola. I said it was parabolic.
You don't be so stupid.
I didn't say it was a parabola. I said it was
Yes, you said it's
parabolic.
all parabolic. They go up and they go down in the ocean in a parabolic curve.
You're freaking out, man.
I'm not.
Logarithmic curve doesn't come back down, in case you forgot that.
I said they were parabolic. I didn't say that it was a parabola.
Parabolic.
A logarithmic curve
It's
is not
the
parabolic.
same trajectory as a parabola, but we know this claims to keep going into an orbit. Duh.
What's it?
I'm sure it's not exactly logarithmic either. It's just more similar.
What's it?
Parabolic.
The rocket starts out vertical, but the orbit path is essentially horizontal.
So it's not parabolic.
That's why it has to follow that path at launch.
It doesn't have to follow the arc length.
What?
It
has to start vertical and has to end up at horizontal. Because the velocity
actually, it dips. It's technically like kind of going down around the ball, right?
It's not. Jake
not
described it. You can see videos
free
of
falling
downrange
around
from the rocket.
ball.
You can see this at a higher altitude. It's not going in the ocean.
But I thought it was free falling around the ball.
That's one. I personally, I'm not uncomfortable with that description, but that's one way of describing an.
Yeah, that's a layman recollection.
It's level.
So
it levels up.
It's free.
It's level as it goes down
Zen
here.
loves it, I'm sure. But anyway, just for intensive purposes, like it's free falling around this orbit. I mean, it's got a parabolic trajectory.
WITSIT, how else would you explain the ISS that people see all the time, and that people like Astronomy Live take high resolution video of with their telescopes? What do you explain that? People see it cross the entire continent in minutes. What would you explain that to be?
Well, there's a light in the sky that people can track with an app that you can see.
It's
all
not
over
a
the place.
light because
the
you
only
can
time
look
that
at
we
it.
can see it itself is in the lunar transit.
No, that's
right?
not true. Look at what Astronomy Live does. He has high resolution video. Look on cloudy nights. Lots of guys have imaged it and gotten high resolution pictures of it. They even have pictures of it docked with the space shuttle.
Okay,
lunar transits
and
are just
so
because it's passing in front of the moon, and that makes for a convenient.
It makes a silhouette, but people take video of it. So what is that?
Okay.
What is it? When the amateur astronomers,
specifically what you're talking about.
when the amateur astronomers, okay, I'll show you some pictures from amateur astronomers. Okay, these are guys on the forums. Even Astronomy Live invited all the flat earthers to come and look through his telescope.
Is this the best we got though? Some dude on a forum? Shouldn't this be just like done all the time by everyone with the best equipment?
It is by the entire amateur astronomy community. There's entire threads on cloudy nights of tons of pictures from different people.
Well, cloudy nights? Why does the clouds help?
That's the name of the forum.
Okay, so it has nothing to do with clouds?
That's one of the most popular forums on for astronomy. They call it cloudy nights because you can't do astronomy when it's cloudy.
Didn't know about the astronomy forum, that's for sure.
What's it? You're scrambling.
I'm literally not.
You can't explain the way the ISS.
Starry Night.
Well, dude, you can't explain the ISS. I don't have to explain it away.
Actually, yeah, I can, and many people in here can.
No,
What do you want to know?
Here's one picture, okay?
It wouldn't even. It would burn up.
Here's one picture from an amateur
It
astronomer.
would burn up. They're trolling you guys.
Why would it burn up? WITSIT?
They're trolling you, dude.
Oh my
Jake
God.
posted a picture.
Wait, can you call him on that, please? Why would it burn
The
up?
coffee mug disappears out of nowhere.
Yeah,
Nothing's up on the ISS.
But that's
Like Tinkerbell's up there, and they're just taking
It burns
acid or
up.
something. Like the
All
camera
around.
took acid or something.
Yes, I know. Something erroneous was said on the internet. We have to stop it, right?
No, when WITSIT says we have to stop it.
Well, no, I'm saying there are glitches on the ISS, and there's coincidences like where
Why
this
would it
little
burn up,
stuff's being. Oh, because you don't want to talk about the glitches.
Look at this
No, yeah.
picture with
It'll-
it. This was done through a 14-inch backyard telescope.
No,
Okay, so
Panic.
this
Jake
right
had-
here,
Jake had the
this
floor.
this
Come
was
on,
taken
So
from
that could
252
see to
miles
the
away.
edge of the flat Earth if it could see that far, then, right?
Jake,
And the
that's
ISS is
why-
really that far.
So wait, so that's 252 miles away.
Yes, Jake.
Okay,
why would-
that's
It
what
was
you
directly
think.
overhead at that moment.
So you think it's
Could be wrong.
252?
Could be further.
Right. So you think at least it's 252 miles away.
It
You
could
can
zoom
try
into a fucking airplane.
I'm just trying to
250 miles
understand.
away.
Like, are you sure that this is what makes you know the Earth's a ball? With all the other question marks that you
Yeah.
just can't deny.
I need to explain what this is.
Well, there's something in the sky, right? And if you look at the trajectory of the ISS over a flat map, have any of you done that?
Yes, actually,
Oh, God.
yes, I have.
Right. So how does it go?
Alright, they're
How does it go?
concentric
How does it go
circles,
from being over Africa to being over Russia a few minutes later?
How does
It
it make a
isn't what
circular
this
path
picture
without a
is
force?
of. There's a
Without
light
a
in the
string attached to
sky.
it? Hey, WITSIT, how does it make a circular path without a string attached to it?
What?
How does it make a circular path without a string attached to it?
without a
Because
string
anything
attached to it.
The forces of nature cause or tell us, dictates that we need a
No,
force.
you're assuming
Correct.
that
Stop
the path
talking
is
over people.
artificial.
But that's what you're doing, Zanuck. You're stepping over Jake.
So what is the string holding the ISS tethered to a circular path?
I feel like the other dude on your team was trying to talk, and you just, what are you doing, man?
You keep on saying silly things, and it's easy to just
calm down, man.
I'm not calm. I'm
Okay,
asking
dude. There's a light in the sky, dude. You're telling me that this right here, this picture, is the light in the sky, and you're telling me this picture right here.
Here's a whole form. WITSIT. Here's a whole form of amateur astronomers that take pictures of the ISS, and they show like when various modules are docked and undocked after NASA and Russia send up, Crew Dragon and Soyuz modules up to it, and they dock and they take amateur pictures of this stuff from the ground using backyard telescopes.
Okay, yeah, you can occasionally see something in the sky. Very occasionally can you get some of the supposed pictures, though.
You can get those pictures every time the weather is clear and the air is still.
Oh, okay, and what are you using to get the picture?
Well, Astronomy Live uses what is it? He uses the Orion what was it?
Digital telescope.
LX200. Yeah, I think he uses a 10-inch LX200, and he actually wrote the software for it for the tracking.
If I zoom in with my P900, can I see it?
You have to have enough aperture.
If I zoom in,
P900 doesn't have the aperture to resolve it because you have something called the Dawes limit, which is
a mechanical telescope would work.
What do you mean by mechanical?
I don't know what you mean by mechanical, but yeah.
The 300 millimeter lens would work great if you could find one.
Oh yeah. So can I see one of those?
A 300 millimeter lens is not going to let you resolve.
You need to have the aperture.
Can I see one that's not a
digital? You need a large aperture.
Does that exist?
What?
Unfounded request. Let me guess.
What do you want to see?
One that's not using a digital telescope.
Why are you trying so hard?
Is that the only way that we can see it with a digital telescope?
No, there's not a digital telescope. There's not a digital camera.
There's nothing digital about the telescope. Just stop for a minute. There's nothing digital about the telescope. There is a camera attached to it, and it's on a computer-controlled mount that just moves.
That's digital.
The telescope itself.
No, it's not digital. The camera's digital.
The telescope itself can be as simple as 2 mirrors.
Okay, thanks for the 3rd grade lesson on telescopes.
Not digital.
But the one you're using and the final product that you get is digital.
No, you look at it with your eyes.
Just because you have a camera connected to it, or you got a computer pointing it in the right direction, doesn't make the picture that you get fake or something. Yeah. And yes, you could. Let me finish. I'm about done. You could just go and look with your eye through a non-motorized mount and see it.
Okay, have you done that? Because I've gone out and looked at the ISS too a few times.
He answered you. You didn't.
Yeah, I have a 10-inch Dobsonian telescope, no computers, nothing, 2 mirrors, and a glass eyepiece.
Can I get Yeah, that's awesome. But there's no. I guess this is anecdotal.
I mean, do it yourself if you want.
He doesn't want to. He's doing everything.
That's right. Are you? Wait, I want to know. Do you guys really think that this is y'all's home run? You think I'm suffering from cognitive dissonance right now?
You have no evidence.
No, y'all really believe I'm suffering from cognitive dissonance?
Just to be clear, WITSIT, will you at least
Thanks for
will you at least admit that you have no evidence that any of this is fake? WITSIT, will you not admit that you have no evidence that
all of it's fake and your home run's the ISS, which I'm supposed to see all the other evidence for? Okay, look at the orbit over the flat Earth. You see it?
You are doing everything you can to resist this a little bit.
You see the orbit over the flat Earth?
It's just
there's a light in the sky that travels super fast. Occasionally you can resolve it. Occasionally you can resolve it.
There's nothing special about
occasionally you can resolve it. Occasionally there's something up there you can resolve. Can you substantiate the altitude of what is up there? No, you claim it's 252 miles up. It would burn up. You lose. I'm suffering from cognitive dissonance.
You are, man.
No, what about the fact that the radius value would be required for NASA to fucking put that thing up there?
Go ahead and talk about something irrelevant.
No, that's a big important part that y'all act like it doesn't matter.
We know what the radius is, okay?
That's what you think.
We know what the radius is.
Okay, so we automatically just guessed it right, and then we're up there 252 miles up. Why doesn't it burn up?
We didn't guess it right. We actually
pick one topic.
We're talking about the ISS. This is the topic.
Measure the radius very easily.
We're on topic. Pick a subject.
No, this is y'all's home run. I'm asking, how could it even exist?
The altitude of the ISS flies at, the atmospheric density is not high enough for it to cause significant heating of the surface.
Does your velocity increase collision rate? Does your movement increase collision rate?
What collision rate? What are you talking about?
The collisions of the particles, although that it isn't that dense, there are particles that are moving super, super fast. So when you start moving through it, you're increasing your collision rate, right? But what's the ISS made of? Particles, matter. What specifically? They have plastic components. So they're hitting super fast.
I pity you that you live in this land of delusion.
What's the problem? So you have this.
They're hitting high velocity particles at 252 miles at 17.
You got to take a stop and make it.
No, you don't want me to. I just want to make a coherent point.
You have covers on it made of.
Yeah, we get it. It has plastic on it too.
Yes, plastic.
Oh, he's spiraling, Zanuck. Watch out. He's spiraling.
No, I'm not.
We got plastic
density.
Okay, what happens? What are these collisions?
Do something.
What are these collisions you're speaking of?
Okay, so the official explanation, of course, we all know is what dude said.
Why
less dense that high, but the reason.
Zanuck, he's answering, man. Just let him answer and then correct him if he's made a mistake afterwards.
Dance around it for a while.
Go ahead. Let me do that then. Go ahead.
So
what is the ISS situation?
It's less dense up there, but the particles that are up there are moving much faster. So if you throw the ISS up there, so nothing's up there. So nothing's like burning up because there's nothing up there. It's not very dense at all. But then you throw the ISS up there, of course, it has density. It's a compilation of matter and particles. And it's just sitting still. Well, it's not really going to get hit by much stuff because, well, there's just the occasional particle there to even come across its path and hit it. But once you start to move the ISS, it's now going to hit a lot more.
Okay, how big are these particles that you think it's going to hit?
A gas particle? What does it matter how big it is?
A gas particle is going to hit it?
That's what increases the temperature.
Okay, so do you know what the vacuum level is in that level of space? Do you have any idea? Do you have the vaguest clue?
Yeah, you just always...
No, I'm going to tell you. And the distances between particles at that pressure level, I can tell you that too.
How?
Because that's what by definition, that's what that level of vacuum is.
Okay, you can an approximation, right? But they're in constant omnidirectional dispersal, right? That's funny to you.
Omnidirectional dispersal.
Are you saying that they're not moving omnidirectional?
You make it up, or is it like
before we go into La La Land, two things that is going to be.
Wait, is the gas moving omnidirectional up there? Yes or no?
That's what I'm know what we're moving to. That's what I'm saying. The gases that it's running into. This is a known consequence, and they have to deal with it because it creates drag on. This is what it does. It just creates drag on the ISS, and they have to lift themselves back up. So it doesn't matter if they're omnidirectional or if they're just staying perfectly still. They're going to be crashing into them. And you're right. It has some effect. It has a drag, a very little drag that they have to apply thrust for. That's thing number one. Thing number two is the gases. Or I'm sorry, the energy coming from the sun that's not heating up the Earth. I'm sorry. The energy from the sun that's coming from the sun is not going to be heating up any air up there that's going to affect the ISS because there's not air up there to have that effect on the ISS. But it is going to be directly hitting the ISS. But things that have no atmosphere or everything at all is going to radiate heat away immediately.
Well, you're kind of off. You're going off the topic. You're a little bit tangential here. There's something called mean free path, and rocket scientists probably knows this very well. And there's one particle for every 10 to the 5 kilometers. That's
okay.
Vacuum. That's what we're looking at.
Every 10 kilometers is how many?
10 to the 5 kilometers.
There's one for every 10 to the 5th kilometer.
Yes. So you're not going to run into anything.
That's not exactly what the mean free path
means. A little bit here.
Oh my gosh, what is this guy talking about?
Yeah, it's the details that are going to matter.
Let rocket scientists explain what the mean free path is.
You obviously you're not in a position to explain it yet.
How about we use a more relatable value. The approximate density of the exosphere or thermosphere up at the level of the ISS is 10 to the negative 12 kilograms per cubic meter.
Okay. So we can't even replicate that on Earth, so we can just guess about it.
Do you know how small that is, WITSIT?
Do you know?
I do.
Well, so compared to the most that we could replicate on Earth, I guess, which is 10 to the negative 7.
What is the density of air at sea level? Do you know?
I didn't give that in torr.
Look, what kind of question is that?
Kilograms per cubic meter.
Like, that's his question?
No, but Slacker had already given you the value for the density of there. I've already given you the consequence that it has in the ISS.
What I said is, how do you replicate?
You hit a particle.
negative 7 torr.
You hit a gas atom. Once in a while.
We can replicate 10 to the negative 7 torr, right?
There's very little force of that. Even if you're going 17,000 miles an hour on a gas particle, that impact, you can calculate the momentum and then the change in momentum. That is the force. That small, tiny amount of force will slow the thing down over years.
I got a question.
All
So
right?
at 10, listen, I got a genuine question, dude. I don't know the answer to this. At 10 to the negative 7 torr, okay, that's what we can replicate on Earth. And so then we have the metrics there. When we go up, what the fuck, man? Can I just ask the question about your fairy tale that you seem to know is real and I'm so stupid for not believing in? So at 10 to the negative 7 torr, we know what it is. And then when we jump up to 10 to the negative 12 torr, then, like, is it exponential? Is like the change exponential?
Change is tiny. And also, it's not that... the vacuum isn't that high.
Or is it exponential?
Yes, it's exponential. It could be trillions of times less.
So it's exponential.
Stop for a minute. Before we get to,
I love this.
Stop for a minute. Before we get too far into the weeds on this, the atmosphere at the ISS is not that high of a vacuum. It's about, according to this that I'm reading, 9 torr.
Okay, so 2 more than we can replicate on Earth. But what's the? It's still though 7 to 9.
Slacker. Please.
7 to 9 is exponential, right? I'm asking a genuine question, but
be addressed. Please stop, man.
Like hyperlogical in my own mind. When I was younger, I used to think. I swear, like when I first heard about flat Earth, when I say younger, so I was like 23, and I was like, dude, just hyperlogically in my mind, the impact would have to be exponential because even though you're just taking away occasional 1 hydrogen atom per cubic meter, right? Like as you get further and further, that 1 atom removed is going to have a more exponential effect on its environment, and it's going to continue to do that. Like I just logically knew that, and so that it is very counterintuitive to then rush that into going all the way up to negative 17 and nothing happening.
Yeah, but the LIGO arms are at a higher vacuum than the outside of the ISS.
So what are they at?
They're at 10 to the negative 11.
So that's the highest.
The ISS is at 10 to the negative 9.
So you're saying the highest we can replicate is 10 to the negative 11? I thought that LIGO was 10 to the negative 7.
That's not what I read.
Well, I did read that.
And there's more than one facility. Maybe they got a better vacuum later on. I don't know.
I think it's pretty hard. It's hard to get to 10 to the minus 10.
You can't get past 10 to the negative 7 on Earth.
I'm talking, WITSIT, 10 to the minus 10 is extreme vacuum, right? So LIGO might be slightly lower. It's possible. I mean, there might be 10 to the minus 11.
It's not possible.
Hold on. The point is you're talking about 10 to the minus 11 to 10 to the minus 17 or 10 to the minus 7 to 10 to the minus 10. What is your problem with 10 to the minus 7 versus 10 to the minus 10? Do you know what that actually means as far as how much more vacuum that is or how much less pressure that is?
It's exponential difference.
What do you mean? What does that mean to you that it's exponential?
That the relationship, its proportionate nature is drastically altered.
Drastically with respect to what? The 10 to the minus 7?
The previous value.
So when you have something that's more vacuum than 10 to the minus 7,
this is so
higher level of vacuum. Hold on. If you
all right, I got to correct myself. It's not negative 11 at LIGO. It's negative 9.
Or 9. Okay.
So same as what's on the outside of the ISS.
Right. Okay, so the same.
I misremembered.
But that doesn't change his argument. The problem you're having
being correct.
10 to the minus 7 to 10 to the minus 9 or 10 or 11. And that, yes, it is an exponential change. It is a tremendous change.
Okay, so the velocity is going exponentially faster.
I'm almost done. But it's a very, very small change with respect to things that we can relate to, like our atmosphere at 14.7 psi.
The gas particle velocity is going exponentially faster, though.
No, why you say it's exponentially faster? No, it's not. The speed
Well, I mean, it's relative to the exponential nature of the environment.
No.
Yes, objectively.
That's not what dictates the speed. You're confused again.
I didn't say speed.
You said speed, exponential speed.
I said velocity.
Velocity, that has a direction component to a big deal.
It is a big difference.
It's not.
We're talking about gas particles.
The speed is
What
not
a
determined by
moron.
the vacuum level.
You're exhausting, dude. When I want to come to try and...
I've never seen anybody get so many things so wrong in my life. Ever.
Also, WITSIT, you need to review the behavior of exponents when they're very close to zero.
You're going to just claim that the differential is negligible, although exponential.
No, I'm just saying, actually go review how exponents behave.
Is that your premise?
10 to the 11 versus 10 to the 7, 6 or 7 more places over to the left. Each power of 10 just moves the decimal one place over to the left.
So that's why
that's significant difference.
Positive to
Slacker,
the right.
Slacker, this is
The
why
reason it's a significant difference is because whenever you have that little of obstruction, right? Like every single removal of obstruction is going to increase the velocity proportionate to it because there's so little. The little removal has so much more of an effect.
Wrong.
Of course.
They create a force.
I didn't say it slowed them down.
It doesn't slow them down.
I didn't say that, though.
It changes their direction.
That's a straw man.
Stop it. If there's more of them or less of them, it doesn't matter. The force can increase if there's more of them, but they're not increasing their velocity. That's your mistake.
So you're saying that the force in the vacuum is from the bumping particles.
They bounce off the ISS. They change direction. That creates a force that acts on the ISS. A very, very small, tiny, almost insignificant, but still something force.
Are you saying that the velocity isn't proportionate to the environment? Please cite it.
No,
Shut
no,
up.
absolutely not. Velocity is its change of distance with respect to time, and its momentum is its mass times its velocity. So when it has a change in momentum, that is force defined. So it's momentum.
So we have two different philosophies here.
Hold on. Whatever the mass of the atom is, times its velocity is its momentum.
Andy Glover's gonna step in.
Doesn't matter if it's in a vacuum or not.
We have a difference in velocity here. You're talking about bumping particles being the active thing that's giving the force, and you're implying that once those bumping particles are gone, there's nothing in the vacuum to affect anything, when the other philosophy, say ether, would talk about the quality of the ether that's still in the vacuum, pulling, tugging, and causing interaction. So we have two different philosophies here, one of bumping particles and one of fluid ether with, a different quality.
Well, we have bumping gas particles. We have elastic collisions of gas particles, and then we have...
Don't respond. Not WITSIT, I'm sorry. Xanic don't respond to that. WITSIT, fucking hell. All right. Yeah, so we're talking about pressure differences and all that kind of stuff. There's a greater pressure difference in any two places on Earth, like fucking from here to Colorado.
Of course.
Colorado, than there is...
Because there's way more pressure,
there
dude.
is from 1 torr to 10 to this negative 17 torr. Okay?
Because there's way more pressure.
Well, yeah, no, the pressure difference in general.
Well, yeah, because there's way more pressure, dude.
The pressure,
bro, the differential. Listen. If you just go a little bit, but there's a lot more of something, then it's going to take up a lot more of it.
You're so confused.
No, I'm not confused, Anik.
Seriously, you're really.
You think if I say something really simple, then I'm confused? I don't know how to. Because you're always confused. You self-project your confusion.
No, I'm not. It's measured in subtraction. It's
okay.
Measurement. So it's not. You don't have to do this division problems or compare them that way. You're literally subtracting one number from the other, comparing those two pressures, and that's the pressure difference. So doing 1 torr or 10 to the negative 17 torr is not magnificently greater than, or it's not greater at all than sea level to Colorado, which has a 4 psi difference.
Our premise is very simple. If you get all the way down to where there's just a few hydrogen atoms, like the removal of one of those hydrogen atoms is going to have a much bigger impact because of the total number being smaller.
Why is that?
Because of the relative relationship of the environment with
Tell me about the
impact
relative relationship of the environment.
Because it's about Dude, are you just trying to obfuscate,
No,
bro?
I'm asking you a serious, calm question. How does removal of one hydrogen atom affect the velocities of other hydrogen atoms in the neighborhood?
No, I'm saying that it's going to remove an entire hydrogen atom. Since there's not many, it's going to have a big impact on the environment because it's damn near void of them already.
Yes, how does it affect the environment?
It takes any warmth out of the system.
Yeah. How does it affect the environment? See, you don't understand how pressure actually occurs. This is the fundamental problem you have.
Wait, is that your response?
Just to give us a little bit of scale, get us back a little sense of scale. You're talking about individual atoms effect on a 900,000 pound object.
Yeah, but the transfer of heat is what I'm talking about.
Well, now we're talking about heat?
I said it would burn up.
I have no problem going there with it. Just go to heat. Now, so there's transfer that atom.
Can you show us your calculation that says it would burn up? How many calories is it taking on per minute?
It says it's going 17,500 miles per hour, but they have the calculations to say that it wouldn't burn up because of their shielding of radioactive shield. And then it says the collisions are so rare that it doesn't really do much. But then your boy, which I'm actually interested, I like to research without bias. So when Zenik came in and said he was going to tell me the actual numbers, I was excited. But then he said some numbers that were clearly just completely wrong. But then no one wanted to tell me the numbers.
I didn't say
no one wants to tell me the formulas. They think they can keep it in their back pocket like a home run. But when they bring it out, then I have to talk through them step by step, and they're never sufficient.
What numbers do you want?
You said a number about there's 1 kilometer, or there's one hydrogen atom every
10 to 5 kilometers.
I know, but Zanik, that's not correct. You're talking about the number of particles of it running into another particle.
I know, but that's close enough for the. God, I don't want to get him confused even more than he already is.
You're the one confused.
I know. Then you explain it to him then, because that's an easy way to explain it to him.
Slacker did. After you said that, he talked about the density instead.
Okay, so anyway, y'all, we can just move on. But I'm just saying, I think one place we can agree is.
That's why I gave it in mass, not pressure.
I think one thing we can agree on is something. We cannot replicate this test by the space agency known as NASA, right? Because
you didn't give it to him in terms he can understand.
we can't actually replicate this claim by the space agency NASA because we can't even replicate past
into this argument about temperature, and he still doesn't have a plausible explanation for what that object is.
How am I deflecting if my original premise was that it burned up?
Well, you're not answering. WITSIT, what is that object that people are seeing? That all those amateur photographers that I posted links to with their pictures, what is that object and why is it flying so fast and so high?
You're just saying that every single time that the light in the sky can be seen, that it is the occasionally resolved.
You're letting him off the hook on the temperature.
What do you mean by occasionally? Anytime anyone sets up the equipment and records it, they get that picture. What do you mean by occasionally resolved?
But you can't see it every night.
It's because it's not over your head every night.
No, when it goes over you, you can't see it every time.
Yeah, they come in clusters, right? So
you cannot make it out and make it resolvable every time.
Where you will see it every night, and then there'll be weeks where you won't.
Can you resolve it every time?
When it gets back to your location, you'll see it. You'll see it for weeks on end.
Can you resolve it every time?
Man. Every time it goes over your head, and it's either in sunlight or in front of the moon, you can resolve it.
Okay, so that's not every time then.
So when you can resolve it, what
y'all are
is
just
it?
contrarians.
I mean, you can resolve it when it's.
You should examine yourself and wonder what makes you be so dishonest.
What is it?
It's the fact you think I can't be right about anything because you mean you might be wrong.
Well,
you're so scared of the idea that I might be right about the Earth.
But this is part of the human condition. People have a preferred paradigm and they make ad hoc rationalizations when the paradigm comes up against problems. It's a natural part of the,
Well, we just want a reasonable explanation as to what this thing is.
Dude,
that everyone in this room has seen at some point.
Right, but Lemon, you can see my thing is like, dude, ironically they act like they hate me. Maybe a bunch of them do hate me, but like I actually come in here trying to help them. I'm trying to help you guys.
So what's it?
Thanks, we don't need
this thing that you're claiming is fake.
I'm saying you understand that's what I genuinely think. You can disagree with me, but what's
the plausible explanation of what this thing is, and what's your evidence that it's fake?
No, there is a light in the sky, I think, that travels, and then occasionally you can resolve something based on what the app can predict, and it's not.
What makes you think it's occasionally? What makes you say that occasionally? What's your evidence that you can only occasionally resolve it?
It's not always.
What's your evidence? What's your evidence that you can't always resolve it?
I've seen it myself, and I didn't try to resolve it though.
Through a high-powered telescope on a tracking and a high-precision tracking
I
map?
preemptively addressed what you're spiraling about.
So you're just making it up. You can
calm down.
You're making it up that you can only occasionally resolve it, right?
Are you saying that you can see it? You can resolve it every time it goes over
If you have the right equipment, you can resolve it every time as long as it's over your head.
What's the right equipment?
All right. Take a shower.
Something similar to what Astronomy Live has.
Hey, can it be every time if you're... Well, listen, he said every time as long as...
Yeah, I mean, there's not much to see if it's not in sunlight, but you can still be able to resolve it.
This dude said every time as long as.
Well, satellites are still
I
possible.
think you actually want to be able to see it, not just resolve it.
Well, I've seen it myself.
But if you can see it once...
I dispute what you claim it is, my friend. It defies the second law and the inverse square law.
Then what is it? What is it? Because it looks a hell of a lot like the space station that NASA says it is. It doesn't look like an airplane. It doesn't look aerodynamic in any way.
It's not an airplane.
And at the same time, we can independently verify that it's going 17,000 miles per hour and that it's 250 miles up. So
no,
what is
you
it?
Can't.
What are you talking about?
You just make stuff up.
What are you talking about? People that are 300 miles apart can measure its elevation angle above the horizon, and they can do the trigonometry to calculate its altitude.
What type of trigonometry?
You don't even have to.
Don't follow down that road.
Because you get decapitated.
Don't go down that road.
Well, the premiere of optical geometry is when the object is overhead. And so if the object is not directly overhead, perspective may F with your angle and the distances and the speeds that are calculated therein. So if somebody's seen this thing traveling down here, say close to the surface at 17,000 miles per hour, or are they just calculating it based off of optical geometry?
So you don't need to do trigonometry. You can use two positions, which people haven't done, where it's at the directly overhead, or 87 to 90 degrees in the sky. You have two positions where it's directly overhead from the span of 10 minutes. That it's 400 or 500 to 1,000 miles apart. And these same calculations can be made without doing any trigonometry at all, just by using even the surface. Imagining if this thing was on the surface of the Earth and the speed it would have to be going, where it's not on the surface and it's going an even further distance. It's going at the very least 16,000 miles per hour, and actually 17.5. So.
You can also verify its velocity just with one observer and a radio. Listen to the Doppler shift.
Where are these? You say these are overhead. What, over the equator? Have these observations been made over the equator for the geostationary satellites?
Do you guys really not hear him doing everything he can not to identify this thing and not to even try to say what it is?
Do you have a plausible explanation? Do you have a plausible explanation as to what this phenomenon is that we all see, and any evidence that it's fake?
Of phenomenon we see, like lights in the sky. I don't have to make up fairy tales about the stars in the sky to admire them.
Specifically, the pictures that we're talking about,
as opposed to.
Okay, are you just going to switch the subject now? Are you going to run away now? Are you going to just run away?
You said explain the phenomena. It's like
what's your plausible explanation for what that thing is that people are photographing? What's your explanation?
A light in the sky.
That's not a light in the sky that I showed pictures of. What are those amateur astronomers?
Okay, so you agree that there could be a light in the sky, and then something different that you occasionally can see.
What's your? What done this before? You have no evidence that it's only something that can be occasionally seen.
Oh my God!
If you see that is just as part of another.
If you see that light in the sky and you have the equipment to track it and look at it, you will see exactly what's in that picture every single time that it's available to be viewed.
So if it's really bright in the sky, then you can. Okay, if it's really bright in the sky and you see it, you can pull out a telescope. You can bring it all the way into view and focus, and it's going to be the picture you showed me.
Yeah, and it's bright in the sky like that for weeks at a time, every few months.
Right. And so how does that work with the inverse square law from 252 miles away?
Fuck the inverse square law. What is it?
I'm asking, how can you make it out if it's... I don't know what it is, but it's not 252 miles away.
It is actually.
How does the inverse square law allow me...
You're a religious zealot.
Hold on a second.
How does the inverse? You can measure yourself.
No one's going to say anything about the inverse square law.
Sure.
Stop talking.
What's it? WITSIT, you can see the filament of a strobe light on the tip of an airliner that's only a few millimeters across from 60 miles away. And we're talking about an object that's a football field in size being reflecting light off the sun. Where's the inverse square law that allows me to see the filament of the strobe light on a fucking jumbo jet?
Yeah.
He doesn't know what the inverse square law is, first of all.
Don't even follow him down that
Wow,
path.
dude.
just
252 miles
diversion.
away, you wouldn't be able to see the ISS
Just
because of
another
the
diversion.
inverse square law. I have to step away for
Don't
a
play,
second,
guys.
so y'all go ahead and
Don't
spiral
play.
and strawman me.
Run away.
Spiral and we're going to spiral now, wondering like, what the hell? How is it possible to help this child understand?
For the record, WITSIT, this is you getting absolutely wrecked.
Help
Not
us
really.
and everybody else, and like we're buddies here. I'm your buddy, Zanuck, and
I know.
That's that. This is a turf war.
Solid and you know who knows what value people
Well,
get.
why don't you mute him?
No, but hold on,
Why don't you?
Zanuck, no one's gonna get any value from whatever they see as value from trying to get their idea out there and trying to express something that they're trying to say to somebody, and only to be
Kosho, man, just
disrupted or trampled over by somebody else. So
Why are you picking me out? I mean, I said very little the last 2 hours.
Danik, it's not even close, man. I'm sorry.
Go
I
fart
like
your
Danik,
feelings
you're
away,
right.
Kosho.
That's not even close.
Not even close. I sat here and
Not
listened
really,
for an
man.
hour.
I
We're talking
understand,
over each
but
other. I mean, and Witch is just going on this
ask everybody
tirade
else.
for an hour or 2 hours, 3 hours.
Ask everybody else here.
Okay, everybody. Argumentum ad numerum. That's a logical fallacy number 1 right there.
Truthfully.
So I believe you. I know I jump in there, but I see so many things that are just so obvious. And I admit,
we all agree with you.
I'm sorry. But you know what? You got to call this knucklehead out for his nonsense.
But you were stepping on Jake.
But
and that's
no,
the
I was
problem
trying to
I
work
had.
with Jake.
No,
I'm
you
sorry
weren't. You were
if I
working
made a mistake
against
on
him.
that. I did. I was actually, hey Jake,
It was
tell him
fine.
this, 'cause I
Danik
don't
was
jump into the
fine.
thing, you know?
It was fine.
Jake, you also you're better at it, but you do it sometimes too. It's not that horrible or anything, but
Yeah, we all do it to each other.
yeah, that's
Look,
what I'm
I don't
saying.
have the golden
I do
throat.
sometimes too. We all want to
I
say
don't have the golden throat that Rocket Man has, and Jake actually listens to as well. I get it. But maybe
unlike
if
you
you
guys,
meet him occasionally, it might be good for
I-
other people to get their thoughts in, so no one's trying to find that one little crack to get in there and get their thought across.
Kosho,
Other people
That's
are
because I wasn't here.
Yes,
all
That's
gotta
what
get better at
lost about me.
even Scott does it sometimes too. We all do it.
I don't do it sometimes. I'm perfect.
Kosho, I've literally
he's a fighter
never.
pilot. He fought in the wars. Remember, right? Veach?
I've literally never interrupted anyone, Kosho. What are you talking about?
Chronic, you're good too. Okay, listen, I'm not gonna point anybody out. I'm just saying, there's something. Maybe
No.
Some people
Chronic.
are
Literally.
and other people are about
Hey,
it.
Chronic. Hey,
I'm not
Chronic.
aware.
Hey, Chronic.
Literally, I've never.
Chronic. Hey, Chronic. Hey, Chronic. Chronic. Hey, Chronic.
What's up, Boomer?
It's Red's course, man.
You interrupt me, but can I finish one thing?
Thank you, Scott Mackey. No, but yeah.
That joke was going to take forever if you didn't help out.
Boomer is not a very nice thing to say. That means
Once I'm
that
committed to it, we're not going to stop until you got to step up at that point.
That's so mean.
So by the way, I listen. I'm sorry, let me go ahead.
Oh, no, you're saying.
I was saying I listened to that for about 40 minutes, 45 minutes, and I just purely not being involved at all, just listening. I mean, there's not much to say. I mean, you guys are giving small criticisms to each other, whatever. But you guys, it's just you guys did wreck him. You guys are asking the same question over and over and over, and he's refusing to answer. He has no suggestion